Here comes the next question. Consider the sequence x of n. The conjugate antisymmetric part of the signal is. You have four options. The question is to find the conjugate antisymmetric part. What is meant by conjugate antisymmetric part? Conjugate antisymmetry. What is antisymmetry? Just for the time being, you just leave the word conjugate. Let's see what is antisymmetric. I will tell you with an example. Um, okay, this is a sine function, right? This is a sine function. F of x equal to sine x. Okay. Here its next example will be next cycle will be like this. Okay. What is the geometry of this signal? Is it symmetric or antisymmetric? Is it symmetric or is it anti? Not asymmetric. It is antisymmetric. It is anti-symmetric, right? Why because um, uh, with respect to the y-axis, if you have this cycle here, then the reflection on about the y-axis will be negative of that. Okay, so this signal is anti-symmetric. And um, what is the signal sign of x? Is it odd or even? Is it even or odd? F of minus x equal to sine of minus x equal to minus sine x, that is equal to minus f of x. So we can see that f of minus x will be equal to minus f of x, and therefore sine x, f of x equal to sine x is odd signal. Okay, so anti-symmetric signals are always odd signals. That is the catch here. Anti-symmetric signals are odd signals. Okay, and in the meanwhile, I can tell you about the cosine signal also. Okay, so in the case of cosine signal, I can draw f of x equal to cos x like this over x. First cycle will be like this. Okay, and its reflection will be like this. Okay, so with respect to the y-axis, here is the first half cycle and here is the second half cycle. So obviously this is symmetric. Okay, this is symmetric, and you know cos x is an even signal. Okay, so I can say that all even signals are symmetric about the y-axis. Okay, so in our question, you're asked to find out the conjugate antisymmetric part. So from the word antisymmetric part, we have to find out the odd component of x of n. Odd component of x of n. Okay. So let us find out the odd component of x of n. So for that we know the expression odd component of any signal is equal to the signal minus folded version of the signal all divided by 2. This is the expression that we are going to use in this particular question. So for that x of n is given to you as the sequence. First sample is minus 4 minus j5. Second sample is 1 plus j2, which is at the origin. This arrow indicates it is at the origin. And the third sample is at 4. Is 4. Okay. Right. This is x of n. Now we got x of n here. The next step should be x of minus n. You have to find out x of minus n. X of minus n is equal to the origin. The sample at origin remains there, and other sample just flip. So 4 comes here, and minus 4 minus j5 comes here. Okay. Now let us see that the question is not just antisymmetric but the conjugate antisymmetric. Okay, so what we have to do is the conjugate antisymmetric part is xo of n is equal to x of n minus x star of minus n by 2. Okay, so you don't just end up in finding x of minus n, but we have to find out x star of minus n, right? x star of minus n because we have to find out the conjugate and the symmetric. So x star of minus n is equal to, how to find out x star of minus n from x of minus n? Wherever you find the j, just put negative j on it. Okay, so the first sample 4, there is no j, so as such second sample becomes 1 minus j2 instead of 1 plus j2, and third sample is minus 4 plus j5. Okay, so this is x star of minus n. Now we can easily find out xo of n obeying this equation, this particular equation. It is x of n minus x star of minus n by 2. Okay, so we have to find out x of n minus x star of minus n. So I can put minus 4 here, minus 1, and minus j2, then plus 4 plus j5. This is minus x of minus n. Okay. I'm sorry. You have to find out minus x star of minus n. So we have to put negative, not here, but yeah, but x star of minus n. I have to find out minus x star of minus n. So minus 4 here, minus 1 plus j2 plus 4 minus j5. Okay, plus 4 minus j5. So we have to add these two signals. That is x of n minus x star of minus n, and finally you divide by 2. Then you will get xo of n. Okay. So what is xo of n? We have to add these two samples, corresponding samples. So minus 4 minus j5, minus 4 is minus 8 minus j5. Okay. Second sample, you add these two samples at origin. So 1 plus j2 minus 1 plus j2 is j4, right? Yeah, j into 4 at origin. And final sample, you add this sample and this sample. So 8 minus j5. Okay, but this is not over. We have to find 1 by 2 also, because there is a divide by 2 here, right? So therefore the final answer xo of n is equal to minus 4 minus j 2.5 j 2 4 minus j 2.5. Okay, so this is the final answer, and in option we can say it is option A is the correct answer.